Welcome to the DIY Honda Garage channel. The DTC, or Diagnostic Trouble Code, P0A94, signifies a performance problem with the DC-DC converter in the Honda CR-V 2023 or newer models. This code is flagged when the powertrain control module, PCM, detects a failure in the DC-DC converter system, leading to abnormal operation. The PCM is an integral computer that manages various functions within the vehicle, including error detection. The DC-DC converter itself is responsible for converting high-voltage direct current from the vehicle's battery into a lower voltage that can be used by various vehicle systems. When failure information is received, the PCM stores the DTC and prevents normal operation of these systems if needed. It's essential to address this issue promptly to maintain overall vehicle performance and safety. The DC-DC converter is a crucial component located in the vehicle's power electronics unit, typically near the traction battery or within the power control module assembly. As it converts high-voltage DC power to lower-voltage DC power, its proper function is vital for systems such as the auxiliary electronics, the vehicle's 12-volt battery, and other components that require stable voltage for optimal performance. The powertrain control module, PCM, often situated alongside the DC-DC converter, constantly monitors conditions and communicates any fault codes through the vehicle's onboard diagnostic system. Understanding both component locations and functions is essential for accurately diagnosing issues related to DTC P0A94. Several possible causes can contribute to the DTC P0A94 being triggered. External circuit issues can arise from wiring faults, poor connections, or any short circuits that disrupt the normal operation of the DC-DC converter. The DC-DC converter itself may also be faulty. Failure could occur from internal component issues or manufacturing defects, affecting performance and leading to error generation. Additionally, a malfunction in the powertrain control module, PCM, is a potential cause. If the PCM fails to process input signals correctly, or if it has corrupted software, it can misreport or misinterpret the data from the DC-DC converter, thereby setting off the DTC. The symptoms of DTC P0A94 can manifest in various ways. Drivers may experience malfunctioning electrical systems within the vehicle, such as issues with lights or infotainment systems due to inadequate voltage supply. There could be noticeable diminished performance of the vehicle's 12V battery. For instance, it may fail to start or maintain charge properly. Additionally, the dashboard might display tandem error codes alongside the P0A94 code itself, indicating multiple electrical system issues. Immediate attention to these symptoms is crucial for preventing further electrical damage and ensuring safe vehicle operation. The first step in troubleshooting DTC P0A94 involves test driving the vehicle and then stopping the engine using the auto idle stop function. This procedure allows you to assess the vehicle's behavior under real driving conditions. It is essential to identify any immediate issues or erratic behavior from the electrical systems and observe if the error code appears right after the auto idle stop. Gathering this data provides initial insight into whether the DTC's manifestation is tied to specific driving conditions or external factors, which can significantly streamline further diagnostic efforts. The second step requires confirming the Health Diagnostic System, HDS, for either a DC-DC converter constant error or confirming a normal operation status. This diagnostic system is advanced and aids in the retrieval of critical information regarding the DC-DC converter's performance. Based on HDS output, if there is a constant error, one can narrow down the focus to the DC-DC converter and associated circuits. Conversely, a normal status could indicate that the problem may lie elsewhere within the electrical system or the PCM, thus ensuring that the inspection remains efficient. In this step, the focus shifts to inspecting the external circuits tied to the DC-DC converter. A critical aspect of this inspection is to check for any shorted wires that could contribute to performance degradation. Utilizing a multimeter, technicians can measure continuity and resistance levels across wiring harnesses. If any discrepancies, like unusually low resistance, are found, this may indicate short circuits that can affect power delivery to the DC-DC converter. Addressing any damaged harnesses or connectors is essential to restore normal operation in line with manufacturer specifications. Next, technicians will perform an inspection of the DC-DC converter, particularly evaluating the output circuit. This process involves checking for anomalies that could indicate which components are functioning improperly. Start by checking whether any aftermarket parts are connected to DC-DC out 1 and DC-DC out 2 circuits that could affect performance. Ideally, these circuits should maintain designated voltage levels. Deviations may signal that the DC-DC converter or related wiring may be faulty. Pinpointing these issues allows for targeted replacements or repairs. This step involves checking the internal circuit of the DC-DC converter. Given that there is no direct method for testing this component, the focus is on confirming various HDS parameter values, such as the DC-DC converter constant error and input-output error codes. If all parameters display as normal, it suggests the potential fault lies within the DC-DC converter itself. Any abnormal readings may indicate issues with related components, in which case further analysis is required. This method of confirming operational states through data provides insight into the health of the DC-DC converter and its associated systems. If previous troubleshooting steps affirm that the DC-DC converter itself is indeed faulty, the next step is to replace the component entirely. After installing a new converter, it is crucial to conduct further tests to ensure that the faults have been resolved. This includes monitoring output voltages and confirming that no error codes reappear in the HDS system. Any recurrence of the initial issues may indicate that there are other related components that have also failed, or that the replacement part is defective. Thus, it is important to utilize a known good component to rule out underlying problems. Finally, conduct a thorough inspection of the powertrain control module (PCM). If all preceding inspection items indicated normal conditions, then discrepancies in vehicle performance may suggest that the PCM could be the root cause of the DTC P0A94. By carefully evaluating the software and connections within the PCM, technicians can identify if an internal malfunction has occurred. If the PCM consistently fails to interpret signals properly, replacement or reprogramming may be necessary. This step highlights the complexity of vehicle diagnostics, where multiple systems interact and impact overall functionality. After completing all repairs related to the DTC P0A94, it is critical to perform a final verification. This includes testing all vehicle systems that could have been affected during the repair process to ensure they operate normally. Clearing all DTCs from the PCM is also crucial, as it resets the diagnostic monitors. After clearing the codes, conduct a road test to confirm that the original issue does not recur. Ensure the HDS indicates no fault codes, verifying that the repair was successful. This final step solidifies that the vehicle is back to optimum operating condition. To prevent future occurrences of DTC P0A94, It is advisable to implement regular checks on the DC-DC converter system and related components. Regular maintenance helps ensure that all electrical connections are intact and that the converter is functioning at its peak performance. Additionally, monitoring vehicle diagnostic reports for any error codes can assist in early detection of issues before they escalate. Keeping a close eye on the DC-DC converter's performance parameters through regular diagnostics is essential for long-term vehicle reliability. Following manufacturer guidelines for maintenance service intervals can prevent similar issues in the future. In summary, understanding DTC P0A94's implications is paramount for maintaining the health of the Honda CR-V's electrical systems. The symptoms associated with this trouble code can lead to further complications if not addressed promptly. Therefore, methodical troubleshooting that involves inspections of the DC-DC converter, its associated circuits, and the PCM is crucial. Replacing faulty components and performing regular maintenance checks can significantly contribute to the vehicle's longevity. Implementing these measures not only enhances performance, but also ensures reliable operation for drivers. Regularly utilizing diagnostic tools to maintain vigilance over electrical system performance is advisable for all 2023 and later Honda CR-V owners. Please like and subscribe to the channel. See you next time.